Good evening, everyone. Shiny from Mydbops here. Thank you for joining us today for the 38th edition of My Webinar by Mydbops. Before we dive into our topic, let me give you a quick overview of who we are. Mydbops is a leading database management and consultancy provider founded in 2016. Over these years, we have had the pleasure of assisting over 800 happy customers. We specialize in providing comprehensive consulting and managed services for a wide range of databases, including MySQL, MariaDB, MongoDB, Postgres, TiDB, and Cassandra, tailored to meet your unique database needs. The topic for today's webinar is Migration Journey to TiDB. This is an incredibly relevant and exciting topic for organizations looking to scale their database infrastructure effectively while maintaining the simplicity and high performance. In today's webinar, Kabilesh will cover an introduction to TiDB, why organizations should consider migrating to TiDB, the migration methods, and the challenges and solutions involved in the process. And I encourage all of you to make this an interactive session. If you have any questions during the webinar, please feel free to drop them in the chat and we will address them immediately. And before we dive into the session, let me introduce our esteemed speaker for today, Kabilesh PR. Kabilesh is a founding partner at Mydbops. He is passionate about open source database technologies and has deep knowledge of MySQL, TiDB, and distributed SQL systems. Kabilesh is an active tech speaker and blogger, well known in the database community. He holds multiple certifications, including being the first Indian Pink App certified TiDB professional. He is also an AWS database specialist. With his vast experience, Kabilesh has helped countless organizations overcome challenges in scaling, performance tuning, and database migrations. We are truly privileged to have him guide us through today's topic. Without further ado, let me hand it over to Kabilesh to take us on this exciting journey of migrating to TiDB.
Thanks, Jenny, for the warm welcome. Welcome, everyone, for our 38th MyDBOps webinar. So today's topic will be migration journey to TiDB. So what TiDB does is empowering scalability, performance, and simplicity. Let's see how to achieve our database to TiDB. So this is a small introduction about me. Already Shiny has covered most of things. I'll just skip this for now. Okay. So these are the MyDBOps services what we provide to our customers worldwide. We have two modes of engagement. One is a targeted engagement, that is consulting, and a 24/7 DBA service, which is a managed services. In consulting services, we handle the targeted projects, migrations, upgrades, etc. In managed services, we offer end-to-end services, operational support to our databases. So we focus on these technologies: MySQL, Mongo, Postgres, TiDB, and Cassandra. So I'll keep the agenda short. So first we'll have a small introduction about what is TiDB. This is for the persons who is seeing the TiDB for a first time and also for the newcomers. And next we'll discuss about why migration is getting trended from moving away from MySQL. And then we'll discuss about the migration methods and how to do the migration process. And we'll also discuss a challenge and solution that I have faced while doing the migration for large enterprises. Okay. So let's jump on to the introduction. Okay, so what is TiDB? So TiDB is an open source distributed transactional database which also supports analytical processing. Okay, and this TiDB is compatible with MySQL protocol. That is, whatever the application you are currently running with MySQL is directly compatible with the TiDB. So this is one of the famous project. This is a GitHub star with respect to TiDB and also TiKV. You can also use TiKV as a standalone project as well. So first I will discuss about the TiDB architecture. Okay. So TiDB comes with a completely decoupled architecture, that is the compute and the storage layer is completely dissegmented, right? Each component can scale individually. Okay, let's see what each component meant for. Okay. So first is a TiDB, that is your MySQL compatible SQL layer. That means this is a layer where your application connects and talks to the database. And next is a PD. PD functions as an orchestrator, or it also can called be as the brain of the cluster. It is responsible for the TSO, metadata, etc. And is next is the TiKV. So TiKV is your key value transactional storage that holds your data. So the TiKV can scale horizontally indefinitely by adding the nodes, and it can scale up to petabytes. So now let's discuss about why migration. As you know, the data is getting ingested onto your application, and every second data is being generated. So the migration is triggered by MySQL limitation. So MySQL limitation is usually hit when you experience a growth in business. Usually, when your scale of users burst, or means when the new business comes in, when you have to accommodate more data into the MySQL, so that is when the limitation hit. So MySQL is not designed for scalability because as it is a shared nothing architecture. Okay. So yes, these are the major reasons for moving out from MySQL. First is the scalability. So MySQL, as I said, it's a single node architecture and shared nothing. Even if you go with Galera cluster or a GR cluster or whatever the node configuration, it is a shared nothing. If you have a three node Galera cluster, it will be all the data will reside in all the three nodes. It does not support horizontal sharding. Okay, so if you have to do sharding, either you have to go for application level sharding, which is very hectic to maintain, or you have to depend upon the third party tools. This is the main reason for moving out from MySQL. And next is a high availability. MySQL does not come with an inbuilt high availability. For example, if when you are on a master slave configuration or a GA, you have to be dependent on the external tools such as a proxy SQL or a MaxScale to help with the master switch or the failovers, okay, which is not automated. And next is the real-time analytics. MySQL does not provide on-the-fly real-time analytics. You have to put a CDC from the current MySQL server, push your data to the via Kafka to Redis or other channels, and then run your real-time analytics, which is very hectic, and management of the external pipelines becomes too expensive. Okay. On enterprise, Heatwave is supported, but on open source version, open source you do not have much options to do the real-time analytics. So now let's discuss about the advantages of TiDB. These are the following advantages that attracts a migration towards TiDB. So first thing is TiDB is completely open source. That is, there is no vendor lock-in. You can use the code, edit it, and reuse it and distribute it. Whatever you want, you can do. And next is the horizontal scalability. That means TiDB provides sharding on the fly. That means by default, when you put a data into the TiDB, it is sharded and distributed among the TiKV nodes. That's the storage node. And the sharding is automated. That means even your application, the underlying the application will not know that your data is sharded. And this data which you have put into TiDB is highly available by default. Okay, and also guarantees auto failover. Even in case of a node failure, or even when you have multi-zone deployments, even your zone deployments will not affect your availability. And even when the node goes down, the node comes back online, it will be automatically added. That means it has a feature for self-healing mechanism. And again, we discussed, right? MySQL, it is always compatible with MySQL. It is multi-cloud. Wherever you want, you can deploy it, whether it's in Kubernetes or on a VM or on your on-prem system, anywhere you can deploy it. And it also supports mixed workload. As I said, it supports both analytical as well as transaction workload. And it has a robust security features as well, like the security features in MySQL, such as uh, encryption, SHA-2 plugin, authorization, authentication is all supported with respect to TiDB as well. So these are some of the global clients that use a TiDB in their production workload. So you can see a variety of customer in which you can to name some. So Flipkart, one of the biggest e-commerce customer in India, say they use TiDB for their production workload. Zomato, again, on the food delivery front, delivery is on the logistics as well as the courier delivery. PayPay is on fintech. You can see TiDB is getting used wherever you have a scale and also in wide variety of use cases. So now let's jump to the core of our topic, that is journey of migration. Okay, so how the journey of migration, I'll just give a brief here, how the journey of migration looks like. For example, these are the steps that are involved. These are the high level steps that are involved in the migration. The first step is that consider you have a MySQL database and you hit the limitations what we have seen, like scalability, availability, and you want to migrate. The first step as a consultant, when you come to our services, we just assess your database. So how compatible is your MySQL with TiDB? So there are certain compatibility checks, and then we do a setup with respect to the TiDB based on your use case. For example, what is your workload? What is the peak traffic? Based on we set up the TiDB cluster and also set up the migration pipelines as well as replication. And third step is the validation, wherein we validate the data, queries, what is the performance of each query, is the index is being properly used. That is third step in the validation. And fourth and final step is a switchover. I said fourth and final step. The fifth step, we do not want to go there always. It's a rollback, and also it is a very important step as a guardrail to have. Even if anything fails or if there is a um, surprise that comes in the production, we'll always have a data in the MySQL that is syncing back from TiDB to uh, the rollback MySQL server with the CDC. Let's discuss each of this step in detail. Okay. So first step is the assessment. Okay. So what the assessments does is, like, the first thing, we get your database and we just audit your database, like have a review of the compatibility checks. First is a primary key. So the basic and the mandatory thing with respect to the is to have primary key for all the tables. Okay, this is mandatory because the global key, or the shard key of the TiDB is depend upon this primary key, and also for the reverse replication for the TCDC, which depends upon the primary key. And also it is a very good practice to have primary key for all your tables. And next is a foreign key. Uh, I would recommend most of the customers or everyone who is consulting me, I'll say that do not have any relationship on the database layer because it can kill your performance. Have all your relationship on the um, application layer. Okay. So though TiDB supports foreign key as an experimental features and it works really well with respect to TiDB, I would recommend to move these foreign keys to the application layer. And next thing is serializable isolation is not supported in TiDB. I think most of them do not use. Most of the recommended this RC, that is read committed and repeatable read isolation level. If there is any specific use case, we can check on this as well. And as distributed SQL, triggers, stored procedures, and user-defined function is not supported by the TiDB. If any, we would recommend or we would help our customers to rewrite them in a better way or with a workaround. And next is the auto increment and full text index. Full text index is not supported. We'll see a detailed workaround how we can do it in the later. And also auto increment. Auto increment is supported. Let's discuss this later as well. Okay. And next is a migration process. Okay, how the migration works. So the migration is handled by DM. So DM is nothing but a tool which is provided by TiDB, which directly integrates with the MySQL. Okay, so this DM is also highly available and it can handle data from multiple sources. For example, I said multiple sources in the sense, for example, you have multiple MySQL servers running and you want to combine them as a single TiDB cluster. You can do this. DM has this provision for this. Okay, so this is the architecture of DM. So DM will have multiple DM masters, that is minimum 3, because as I said, DM is a highly available service and also it can be easily deployed with the tie-up. So tie-up is a management tool for TiDB. So the master is responsible for scheduling the migration task, monitoring the DM workers. For example, if there is any failures, for example, if there is an ongoing replication or ongoing data migration going on, and if one of the DM workers goes down, the work which is done by the DM worker will be automatically switched to the other DM worker, which is available in the next zone or the available server. So that is how the high availability is maintained. And this DM master and DM worker, they can be deployed on a host or a Kubernetes or anywhere you like, or as a service combined with other nodes as well. Okay. So now in the next slide, we'll discuss about a typical migration process. What is the underhood working of DM? Okay. So you have your MySQL source server with binlog enabled. So binlog is needed for the incremental replication. And when you connect to the DM, the DM has internally uses two tools, that is uh, dumpling and lightning. So dumpling is nothing but to dump and lightning is for the restore. And on high level, so dumpling is similar to it's based upon the MyDumper. It's a multi-threaded dumping tool for MySQL. It is rewritten in Go by the PingCap team, and they efficiently use it. So dumper first connects to the MySQL and dumps out the data, that it pulls out all the data and writes to a SQL file. From the SQL file, the loader or the Lightning loads the data into the destination. That is our TiDB server. The backup, the dumper stores the bin log position, that is a consistent bin log position to which the backup has been taken. From the backup position, with the use of bin logs, it collects a bin log and writes it as its own relay log in the worker node, and then the syncer will read the relay logs and apply to the destination. Thereby, your TiDB will get attached to the MySQL server as a direct replica, right? So wherein there will be live replication ongoing from MySQL to the destination, that is our TiDB. This is the migration process. Okay. Now let's discuss about the migration the import modes as well as the migration modes. Okay. So there are two modes of import which DM supports. One is a physical import and other is a logical import. So the physical import, the SQL files we saw, right? These SQL files will be directly encoded as a key value pair files, that is SST files, and it is directly imported to the storage layer. Okay. And in logical, on the other hand, for the logical import, it's similar to an dump ratio. That means the SQL files will be replayed onto the TiDB and the data will be imported onto the TiDB. So the task file, that is the DM task file which you create. So you have to mention the backend as local for physical import and TiDB for the logical import. And the speed part, physical import is much more faster than the logical import. Okay, let's see. And when you do the physical import, the resource utilization of the node, that is basically not the MySQL node, on the restore node, that is the TiDB nodes, will be very high. And the network usage will also be high because the files will be inter-transferred between the nodes of TiKV. And ACID compliance, when you see physical import does not follow the ACID compliance, wherein logical, as it's a logical import that SQL is being replayed, it follows the ACID compliance. And for the physical import to work, the target table, the whatever the table which you are going to do, right, which it needs to be empty. There should not be any data onto that. And logical import can work even with the data. And TiDB cluster version, for example, physical import is supported from version 4.0, and the logical import is compatible with all the versions. Service availability is physically, when you do a physical import, the engine mode will be switched to import mode, so that in a short span of time, when the import is happening, the data will not be available. So the server will not be usable when the import is going on. And on the other hand, logical import, you can use a server when the import is on. And the task mode, it supports three task mode. One is a three task modes, full, incremental, and all. So full is basically, we said, right, this first process, just it takes a full dump and restore it to the TiDB, that is full. And incremental is, so you have a backup copy. For example, yesterday's backup has been successful. You have a logical backup, or you restore the backup, you have the bin log portion. From this particular bin log portion, you can just start the incremental portion. Means the ongoing replication can be started from the bin log. So that is incremental. And all is combination of both, that is full. And when you make the task mode as all, it will take a full backup, restore it onto the TiDB, and then it also starts a replication from the bin logs. Okay, this is best scenario for live replication and for the cutovers. And it is all mode is preferred for the production. Okay. So now we have done with the migration. So the migration is done. Now next step is validation. So you can run as much validation step as possible to make sure that your data is compatible, your queries are compatible with respect to your TiDB. So also along with the DM, the DM also supports a validation mechanism that is for data validation. It runs a checksum between the source and the destination to see the data is matching between them, and this is a very slow process. Okay, and next there is a tool called sync diff inspector, like similar to ptdiff. There is a sync diff inspector where it can compare between the source and the destination, that is source MySQL and the destination TiDB post the migration, validate for inconsistencies, and also it can provide files. Like if there is an inconsistency file is found, it will provide a SQL file, direct SQL files to be executed on the destination. And also you can do a manual validation, like some like counter validation or running some queries from your application or stuffs like that. As I said, the data validation time varies depending upon the dataset size. Okay, again, if the data validation is completed, next is a query validation. With respect to the query, there are two aspects. One is a functional aspect. You just check whether you run the query and get an identical result between the MySQL and the TiDB. So this is the first step. And second is the performance test. So performance test is basically what is the execution time difference between the MySQL as well as the TiDB and capture any regressions. So in most of the times, what we have seen is TiDB is giving a better performance than MySQL. The reason being, TiDB is a distributed architecture. It's not dependent on a single node for the data. It distributes the load among the nodes and get you the data. So most of the time, we have seen the performance is outnumbered in TiDB. In certain cases, we see a regression for some queries. This is because the optimizer of MySQL behaves differently and optimizer of the TiDB different behavior differently. In these cases, you might need to change the execute means rewrite the queries with respect to the index order or add a new index. That is possible. And the third thing is the read traffic. So for the production workload, so we did a migration in which we used proxy SQL for MySQL. In the same proxy SQL, we created a reader host group separate for TiDB, and we started routing with 10% traffic and increase by 20% after 30 minutes. And just we monitor the performance to ensure that read traffic is completely works fine with respect to the TiDB. And also you can do a dual reads from the application as well to monitor the performance of TiDB. Okay. So now your validation is completed and the system is ready for switchover. So I'll just cover the switchover steps. Okay. So usually the switchover we have done is spans between like 2 to 3 minutes. Okay, basically that is to the max. It will be just a change of endpoint from the application from MySQL to TiDB. So here is a depiction. The first your service connects to MySQL and you can just validate the DM replication. So DM replication is asynchronous and it can have some delays like 1 second or 2 seconds delay based upon your data. Okay, so here I have not discussed about the rollback server. We will just discuss it later. So first, the DM replication is continuously happening. We are going to do a atomic switch. The atomic switch is nothing but the service or the writes from the application will be stopped momentarily, like say 1 or 2 minutes, and then it will be pointed to the TiDB. So here in the step two, you just stop the application writes and the replication, we just monitor the replication and the replication catches up maximum like 60 to 90 seconds max in most cases. And then you point the application, you stop the replication between MySQL and TiDB. That is a DM replication which is happening. You stop them and then you point the application directly to TiDB and just monitor the write flow as well as the matrices. Okay. Now let's discuss about the rollback. Okay. So we have not done any rollback. I do not want anyone to go to the rollback step to make a rollback, but it is always a good guardrail to have. Okay. So MySQL supports a mechanism called TACDC, that is change data capture, to replicate from the TiKV or the TiDB clusters to the downstream. So downstream can be anything. For example, it can be your MySQL server, it can be your TiDB server, or it can be your Kafka. As well, it can also write as a SQL files to your cloud storage or S3 bucket, etc. Okay, so how does this CDC works is the CDC gets attached itself to the PD, that is the metadata manager, and from the metadata manager, it gets the information of the cluster and it collects a change log, TiKV as a change log. From the change log, it collects and converts it to the SQL format or the format which is needed in the downstream and pushes it to the downstream. Okay, so this is how the rollback works. And now let's discuss about the challenges and solutions. Okay, so we had faced some challenges during our production migration. Let's discuss them. The first thing is auto increment. So by default, auto increment is batched in TiDB. That means, for example, if you have 3 TiDB servers, the first TiDB will have a batch from 1 to 3000, second will have from 3001 to 6000, and third will have from the 3000 9000. So this is how the pre-batching and allocation works with respect to the TiDB. Solution to have is, for example, when your application is completely depend upon the auto increment or explicitly depends upon the auto increment value from the database layer, you can enable this auto ID catch. This value is enabled per table while creating the table. Okay, so you can see here just an example. Sorry, you can see here we have a table definition wherein we have defined the auto ID catch is equal to 1. Okay, so now so this table with auto ID catch is equal to is enabled as 1. So now the auto increment ID will monotonically increase with respect to the MySQL. That means it will have the MySQL compatibility. Okay. So even for one of our customer, when he had this auto ID cache is being enabled for table, we had an issue. That means we had a major issue. I'll just explain. We created a bug, this 56814. So wherein you can see the table structure with the auto ID cache. So this was the ID like 1460994. This was the ID till the replication was happening in MySQL. When the application was switched, that means when the writes were directly pointed to the TiDB, we see a sudden jump in the ID. Means like you can see it jumped like more than crores. Okay, so this behavior was seen in the TiDB. We immediately filed a bug and we followed up with the PingCap team on this. Okay, so what we did immediately was, so as the ID was incremented drastically, we had to force down the ID. This is just a workaround. So we forced down the ID back to the lower value, and then we sit back with the customer and we found the discrepancies in the amount of records to be updated, and then we wrote a Python script to uh, back to mismatch match the IDs back, and we immediately ping like Max is the CEO of PingCap, and I gave this bug. See, actually, Max, we are facing this issue in the production. This is very critical. So I gave this bug report on about 26th October. Okay, this was filed, and I just reached him on LinkedIn. He immediately responded back that our team will be working, and in next 3 days, the bug was reproduced, located, and they have sent up immediate patch for this on the Lightning. So actually, it's a issue with the Lightning. Okay. So I would like to extend my heartfelt thanks to Max and PingCap team for this immediate turnaround for a community request. Thank you, Max. Next is the regressions. We discussed about the query regressions. There are certain regression possible. So we have also seen this regression in terms of queries performing badly with respect to TiDB. The solution is in certain cases we had to rewrite this queries, okay, without losing the context of the outcome. And in certain cases we might need to change the joining conditions like left join, inner join, those things, and also the where class ordering in certain cases has to be replaced. So that worked well. And another important two things is descending index. Okay, in TiDB currently descending index is not supported. The solution for this is the main solution is like you can have the queries rewritten, or you can range the queries or sort the queries based upon the timestamp, right? That is one method of doing it. And next is the full text index. Full text index is not supported with TiDB currently. You can integrate with external services like Spinix or Elastic Cache or Solar to provide this competency in the TiDB. Next, as I said, right, what we achieved with the migration, we have discussed a lot. Let's see them in action. Okay, so I'll discuss a production use case. So to say a little about the customer, Yulu, you might know about Yulu. So they are into micro commute, providing electric bikes for the, it's based upon IoT data. So bike emits data at a per second from, they have around 1 lakh bikes on road from, they are operating in around 6 to 7 cities currently. And you know the scale, right? So it is very IoT intensive and very ride heavy. So these are the challenges faced by the Yulu team. The Yulu team was in RDS MySQL. The data set size, the entire data set size, including the transaction data, was close to 40 terabytes. Okay, and of which we have mentioned 18 terabytes. So 18 terabyte is for the log data. So the whatever the bike runs, right, they send a log similar to a heartbeat. Like this is a distance, this is a mileage and batteries, and those details are sent as a logs. So that consumed around 80 to 90% of their total storage in MySQL. And they had performance bottleneck. For example, as it's not a distributed SQL, like MySQL writes were stalling at times, they had to restart the system. The restart was very slow to handle 40 terabyte of data. And DDLs, the DDL operation, that's adding an index or adding a column with respect to the those tables, like bigger tables, was a nightmare to them. and cost. As they when there is a sudden spike or there's an undefined spike, they have to always upscale the instant. The cost of the scaling comes into the picture, and also the downtime which comes along with the scaling, they have to manage it. And availability. So for example, in RDS, uh, we have seen issues with them, like RDS goes for a stall immediately, the availability is limited, right? Okay. So we deployed, like, we provided our service on TiDB. So what are the things we did? We deployed the TiDB based upon their workload requirement for the log tables. Okay. And we made a live replication to them for those particular tables. DM has this facility to make a filtered replication as well based upon database table. Even at row level, you can have filtering for the DM to work. And we synchronized the operation. We did a data migration, and we optimized their TiDB for their workload, particular workload. And what was the achievement was, like, their log data completely moved out from the transactional data, thereby making the transactional server very light, and the log data was completely scalable, for example, without any impact, and have a high reliability. Even if there is a node goes down, we had a reliability testing also done onto the TiDB cluster before the migration, like bringing a node down on a particular AZ and bringing it back and testing the back and forth. And one important aspect is, like, so that 18 terabytes of data which was in MySQL was translated to TiDB, that is with RocksDB storage, to around only 3.4 terabyte, which is around 72% of storage saving. So they had huge cost saving. Okay. And also comparing to the RDS and to the TiDB cluster, so they have saved around 50% on their RDS cost, moving to a self-managed TiDB cluster. These are all running in the open source version. So, and we are continuously monitoring and managing the server till date. Okay. So this is what we achieved with respect to TiDB. So there are also multiple case studies which is in pipeline. Thank you, guys. Any questions?
Thank you, Kabilesh PR, for delivering such an insightful and engaging session. Your expertise and detailed walkthrough of TiDB's architecture, migration processes, and real world challenges have been incredibly valuable. Thank you to everyone who joined us today for MyDBOps My Webinar Edition 38 on this exciting topic. We hope you found the session informative and are taking away actionable insights, to explore and implement IDB in your database journey. If you have any further questions or require additional information, feel free to visit our website at www.mydbops.com or email us at info@mydbops.com. Lastly, I would like to remind everyone to subscribe to our YouTube channel for more insightful content, including recordings of past webinars, technical tutorials, and updates on upcoming sessions. A big thank you once again to all the attendees for making this webinar a success. We look forward to seeing you at our next MyDBOps webinar. Have a great weekend. Thank you.